Hello, everybody. Yes, as mentioned, I'm Kurt Kraler, project manager at ERA Architects for the past 9 years. I'm excited to be here tonight to share some of the work that we do at ERA and some of the work that I've done over the years, plugging in the research I started under my thesis into my professional work, which I thought would be of interest to you who are currently studying at the School of Architecture. And everybody can hear me okay, right? Yeah. Okay. So I'll start with a bit more about the firm itself. I know that was a great introduction, but a bit more about who started the firm and the ethos that sort of developed to produce the office that we have today. So ERA is an architecture, landscape, and planning firm. So we have a multidisciplinary approach to a lot of our projects. And we tend to focus on the conservation of historic places through their reactivation. The firm started in 1992 with Michael McClellan and Edwin Rose. And in fact, Edwin Rose's name is the initials ER and A for architects. This was their first business card, highlighting their focus on the conservation of historic places. And over the years, the firm has grown from those first two people to well over 120 people now. I have to update this slide. We're closer to 140 now across our various offices. So we continue to grow and focus on centers outside of the city of Toronto. We have offices, a small office in Ottawa that focuses on more federal conservation projects. We have a Montreal office. We have two people that have an office that they rent in Calgary. So it's an upstart in Calgary that just opened the last few years. And of course, our biggest office is in Toronto, where we have most of our office. And our studio culture is a way to split up what would feel like an overwhelming large office into smaller studio-based teams. So we have 5 studios that are practicing out of the Toronto office, and each studio has this area of expertise. So once you join a firm like ERA, there's a bit of jostling around trying to figure out which team your skills are best suited, and then you then get to know your team. We host a lot of socials and make an effort for team members to spend time outside the office together and just sort of build those bonds. And the other thing that we do too is a lot of community engagement and outreach. So with Toronto the Good Party is one such initiative that's taken on a life of its own over the last 25 years. The parties have been hosted all over the city. So from the Distillery District to last year where we had a party under the Bentway, so it was outdoors. And the goal of the party is to bring together policymakers as well as fellow architects and urban enthusiasts, artists, so trying to bring different communities together under the guise of architecture. Other initiatives that we have as an office, there's several. I'll point out some exciting new initiatives that have taken on a life of their own, which is Friends of Allen Gardens. I'm not sure if anyone has been to the farmers market, but every Saturday morning there's been a winter's farmers market as a result of an initiative that ERA was behind, as well as the Frank Darling book project, which is coming out this December. So keep an eye out for more information about that. So there's constantly these small initiatives that the office gets behind and continues to advocate for the preservation of historic spaces through various initiatives, community collectives, publications, which I'll get to more about that. And then as I mentioned, a lot of our projects are spread out across the country. We even have a few projects in the US and mostly centered around the GTA and Ottawa area. If you look at our website, here are the sort of 10 categories that we've been able to identify as the key sort of sectors that we work within. This is by no means the exhaustive list of projects that we have, but if we look at these 10 projects, there's a range from adaptive reuse to legacy institutional projects, to tower renewal, and upgrading existing social housing projects to meet current energy standards. What I thought was I would go through a few key projects just to talk about the range of projects that we have. And I thought we'd start with the one that we're in right now, which is One Spadina. And this was a project that came out of a collaboration with NADAA, and the building focusing on the restoration of the conservation strategies that would preserve the building once it was given a new life as Daniels. This building is originally from 1875, and it's great to see that it's taking on a new life. Another recent project that was completed was 19 Duncan. This was completed in collaboration with HPA, Hariri Pancharini Architects, and was working on rehabilitating and conserving the 5.5-story tower, which is again a fine example of a warehouse building of its time. So a lot of this work was centered around the revitalization of the podium of the building, and you can see that the new tower stands very tall behind it. And a lot of our work is advising the architect, the prime architect in this example, on the placement of the tower so that the historic facade remains the most prominent at street level, and then the new fabric isn't competing with the historic fabric, that there's a clear distinction between the two building envelopes. There's another high-profile project just at the south end of the Eaton Center, so at Queen and Yonge. You can see there's a 2-story addition on top, and then the recreation of the original facade, which had been heavily damaged and modified over the years. So this was brought back to its original state through a lot of historical research. And in this case, there was a significant photo that we would always refer back to when making decisions on the design of the new storefront, as well as the signage band and other details. There's another exciting project at 69 Yonge Street. So this is an office tower that's being converted into residential suites. And so this is in collaboration with Partisans Architects. They'll be designing the top-up addition. Well, ERA is focused on the conservation and the adaptive reuse of the historic office tower. So keep an eye out for that one. There will be lots of developments over the next few years on that project. This is a personal favorite of mine. This is at Yonge and Adelaide. And so there's significant relocation of the building facade around the block to accommodate the new building. And as a result, the reinstatement of 3 bays of the original building was required. And the approach in this case was to interpret those 3 bays as a cast of the remaining facade, and replicating but not duplicating in a way that the new envelope gets confused for part of the original facade. So that's a lot of the conversation that we have, is to create a distinction between the two buildings, but also continuing that rhythm and that character across the streetscape. We also work on large federal projects. So this is the center block in Ottawa at Parliament Hill. And it's actually one of the largest in Canada and the most complex historic projects. And it involves a comprehensive rehabilitation of not just center block, but also both wings, and includes upgrades to the building systems, as well as the ongoing use of the building. So as heritage planners and sub-consultants on the file, ERA was responsible for the preparation of a background analysis report, a review of the LiDAR scan, a conservation management plan, and heritage impact assessment. So this was more on the planning side of things before getting into the execution of the project. And then we also have more community-focused, landscape-driven projects. So this was a community-led project that's situated in the heart of Manitoulin Island, and ERA was the project's lead landscape architect. So this is another small team within the office that focuses on community engagement and landscape design. So the work of an Anishinaabe artist here was featured prominently in the project and was a result of an extensive public engagement process at the beginning of the project that led to the identification of an artist from the community that would be able to contribute their artwork to the project itself. And so that's an ongoing theme throughout a lot of the landscape team's work, is reflecting local community through the design. You may recognize this building from the brickworks. So this is building 16 in partnership with LGA Architects. And in this project, there was a dual purpose. So adaptively repurposing the project to become an event space, but also incorporating flood mitigation measures. So you'll notice that the new concrete floor is actually raised, and the original brick firing kilns remain at their original level. And so to mitigate for flooding, there's actually hollow bubble deck underneath the concrete slab to allow for water to pass through rather than flood and take over the slab above it. And another case for this project was to provide some insulation and enclosing it so that it could accommodate some large events. And then there's also smaller projects like this cottage in Pointe-à-Barrel in Northern Ontario. And so this was a cottage project that's on a remote island that can only be accessible by boat. So a lot of planning had to go into how to ship building supplies and materials to the site. The team even got to spend some time on the site because of the length of time it took to travel back and forth. So they had a wonderful summer working on this project, working directly with the contractors. And then a bit more about my own personal portfolio within the last 9 years. It's been a range of projects, working on a new cottage for a private client of ours, to the design of a contemporary addition to a historic farmhouse in Oakville. There was an urban infill project which replaced a building that had burned down on Yonge Street, but because it's in a historic conservation district, the new building had to fit within the character. So we were looking at a way to design in a contemporary language, but picking up on some of the rhythms and patterns and materiality of these surrounding buildings to reference. And then on the far side is an exploration of intensive housing intensification on a whole building retention. So that's an approach that we're looking at pushing further, is whole building retention instead of facade retention, which tends to be a more sustainable approach. And then also exploring how structurally a new tower could be built on top of the existing building. So that's been an exciting project to work on at the moment. And I wanted to also just reiterate and overview the scale and the types of projects that ERA works on, not just historic, but there's a lot of new construction as well, especially in a historic context. So designing for a heritage conservation district, for example, or in a rural community. And also the scale spans from single family residential all the way to Parliament Hill. Another aspect of our work that continues to grow is the use of LiDAR scanning technology. We have people in the office that specialize in the use of the technology and are willing to advise on specific projects. This is a great image that someone pulled together for one of our socials to show off the latest work that they've been doing with the LiDAR scanner. As you can see, the initial scan then being traced in Revit, and then you're left with a set of measure drawings that you can then take into conservation and construction. There's a beautiful example of one of our more complex projects, the Royal Vic in Montreal, and you'll see just the layers of details and the information that is communicated through historic conservation drawings. And that all starts with a set of measure drawings that accurately recreate the building as is. Another aspect of our work is obviously intensive research and background analysis of a given building typology. So we have a series of type studies that we pulled together over the years to help inform the project team, the architects, the other consultants on the team about design decisions that are being made on the project and informing an approach early on in the project. And we do this through developing type studies. So if we look at the residential format and how apartment buildings have evolved over the years, that's one case of a type. Another is the rural historic Ontario farmstead typology, and looking at what makes Ontario farmsteads unique compared to other rural types. And then we also get into office buildings, and we're now incorporating modernist office buildings as a historic type to be preserved and explored, and also looking at brick mixed-use warehouse buildings as another type. And what we do is go through and identify the key characteristics of each type that should be preserved or maintained in a heritage asset. Another aspect of our work is publication, and this goes into reaching out to a broader public and educating them on the city that they see around them, and also advocating for the importance of housing as well as historic preservation. And so here are a few examples of publications that the office has put out over the years, including Concrete Toronto, advocating for mid-century modern brutalist buildings, as well as The Ward, which Michael McClelland wrote extensively about the neighborhood where the City of Toronto currently, the City Hall currently stands. And then House Divided to raise issue with the missing middle aspect of our housing supply in the City of Toronto. And so that's where my book, The Signs That Define Toronto, comes in. This was an extension of the work that we've been doing as an office to advocate for heritage preservation. And where this all came out was from a lot of the research I had done during my graduate thesis at the University of Waterloo. So this was a snapshot of some of the diagrams that I produced, exploring the evolution of the hotel resort typology in Las Vegas, of all places. Now, this doesn't necessarily lend itself to historic preservation, but through a lot of my research, what I started to understand was the importance for heritage conservation through a city that looks to demolish a lot of its historic buildings, and understanding what is lost when a city doesn't have a lot of those historic buildings in the main strip to recall its past and to communicate where it once was. And of course, my thesis took a lot of direction from Learnings from Las Vegas, which was published in 1972, and sort of picking up where it left off. And so a lot of the exploration at that time was looking at the relationship between signs and building, and the importance of signs in modern architecture. And as you can see, as it's displayed here on the Las Vegas Strip, you can see that signs have become the most prominent part of the building at that time in 1972, when the book was published. And so that led to an understanding of the relationship between the sign and the building, and that the sign is actually what remains when buildings get demolished. And so in a city like Las Vegas, where a lot of buildings are imploded and a bigger, more exciting building gets put in its place, there's an exciting project in Las Vegas that's called the Neon Museum. And this is a shot from the museum where they gathered all the discarded signs, and you're able to do tours. And on those tours, they tell you the history of the sign and the business that was associated with it. And so then when I started at ERA, I started to think about a lot of these historic photographs that we come across in our practice, and just how magnificent some of these signs were from the city that we no longer have, and starting to think about how we could communicate that history to the city in a format that's accessible. And so that's where the idea for the Signs That Define Toronto came from, was to take a lot of that research that we had already started to do and present it in a format that could be made accessible. So I'll just quickly go through the book and then we'll wrap up. The way that the book was laid out was set up in a series of 8 chapters, and they go in chronological order based on signage technology. So we start with the earliest painted signs, followed by the electric marquee and neon signs. And then for more contemporary signs, we thought we'd focus on 3 specific neighborhoods with distinctive backlit signs, including Chinatown, Little Jamaica, and then expanding further out to the suburbs. And then we end up with looking to the future at Yonge and Dundas Square and the use of LED technology to advance the trade of making signs. We also do a feature on some of the iconic signs of the city. Like we have the Real Jerk sign here. We've got Honest Ed's, El Macombo, Sam the Record Man. And we get into the stories behind these signs that people recognize, but may not necessarily know the history of the sign and how that design came to be. We also pulled in various collaborators and people that look to document and make signs. And we also have Linda Zhang here, who documented Chinatown through LiDAR scanning. So we thought that was a great way of using a technology that's used to document historic buildings, but then extrapolate it into Chinatown futures. And then we also featured some of our own projects just to show what is involved in the restoration of a sign. And I'll end with the Paradise Theater sign. So the condition that the building was found in was the one on the right. So the original sign had long been removed, and the only evidence we had of the original sign was this black and white historic photograph. So naturally the challenge becomes, how do you select colors for a sign that you've only seen in black and white? And so then that led us down a path of doing extensive research on similar theater buildings that were built at the time, and also matching the contrasting tones of the original photograph to come to a conclusion, a very educated guess on what the original sign would have looked like. So this is a great example of the research being applied in a way that is very concrete and evident in the final product. So I'll end with that, and feel free to reach out to me if you have any questions beyond tonight, or if you think of a great sign that you want to talk about. Always happy to chat about signs. You can follow the book project on Instagram at Signs That Define. We're always adding new signs that we come across, new stories. So be sure to check that out. And of course, you can find ERA on most major social media platforms, and you can check out our website. Thank you.
So I've never had a chance to work with you, Kurt, but we've worked with ERA so many times, and huge amount of respect for what you guys do. So thanks very much. I guess we can a little bit of background on ourselves. So I'm a U of T alumni, graduated in '97, which makes me old, I guess. I've been with KPMB since 2005. And yeah, I've had an opportunity to work on a series of projects that focus on sustainability. My first project when I joined the office was the Manitoba Hydro Place in Winnipeg, which was finished in 2008, but it's still one of the highest performing large office buildings in North America. So I think that's really kind of shifted my perspective and on how an architect can approach their work and work collaboratively with other engineers and client groups. So I think that was a real learning experience for me. It's dark in here. So yeah, we're going to talk about a few specific projects, and Shahrzad and I are both kind of contributing members of Lab, KPMB Lab. So we're going to talk a little bit about what makes that unique within the industry, and then how some of the lab workers contributed to some of our projects. Shahrzad?
Hello, everyone. Thanks for having me. I'm Shahrzad. I'm a sustainability analyst at KPMB. So I started as an architectural engineering student back in Iran, and when I came to Canada, I was always interested in vernacular architecture and its inherent sustainability, and I was specifically looking to continue my education in sustainable architectural design, and I continued to building science, and then I changed the trajectory to mechanical engineering, where I worked on different fields, especially working with adaptive and responsive building facade systems, and how the thermal heat and moisture transfer basically can be controlled dynamically. So that was basically my research. But after that, working within an academic environment for almost 10 years, I realized that I really need to get a new perspective and see how research actually gets applied into practice and what actually happens throughout the whole process of building. So I was really fortunate to get this position at KPMB, where I work with KPMB Lab, where I can work with the design projects, but also do a little bit of research. So it's very rewarding. So I'm happy to share that experience with all of you.
So we design built environments that catalyze positive change. I guess that's our company tagline, I guess. But I think when we talk about, I think it's important to, when we talk about architecture, to not just talk about buildings specifically, but to talk about environments, because that's what we're really designing. We're not designing objects, we're designing places. So I think when we talk about environments, we can take that very broadly to cover a very large canvas, because I think as architects, we're put in a very privileged position to impact change, but with that position also comes a lot of responsibility. So I think we need to think very carefully about what we're doing and how we're doing it. A little bit about KPMB, founded in 1987. We are currently about 150 employees. We have one office in Toronto. And I think over the years we've accumulated more than 31 million square feet of built project. We cover a really broad kind of, by design, we intentionally cover a very broad range of sectors. So everything from education and healthcare to research buildings. We do a lot of, we have in the past done a lot of corporate or kind of commercial office building work. And recently we've been doing a lot of residential development as well. Not historically something that we've been doing, but we've been moving into that area as well. So just a little bit about KPMB Lab, which is pretty unique in the architectural industry. We decided about 7 or 8 years ago that we realized that the industry was changing very quickly, and we needed to have a mechanism, a way of kind of keeping up and keeping current. And also we saw the value in investing in research within the office. So KPMB Lab was born out of a desire to kind of keep us competitive, but also to start to think about how we might, as an industry, not just our office, but our entire industry, react to the climate crisis in particular. So I think a large portion of what we do in Lab is focused on the climate crisis, but it also has a lot to do with how we develop process within the office and how we approach our work. I think broadly, how does KPMB Lab work? So the idea is that we have a few select people in the office that are kind of assigned to Lab, but across the entire project, the intent is that Lab has some involvement in all projects in the office. So we're there as a resource, but also to help provide research, to do analysis, and then we also have a kind of strong presence both in academic research and also in industry research. So we're actively involved in a whole series of kind of academic research groups, but also involved in some kind of industry groups such as the Toronto Circularity Network, Toronto Bioboat Collective, a number of other kind of industry groups as well. And the focus is that we want to, it's not research for the sake of research, it's not academic research, it's not kind of tangential or esoteric research, it's research that is focused on very pragmatic and applied outcomes. So we focus on opportunities and successes, and we look for opportunities within projects to develop research. And ultimately, we are kind of a catalyst within the office, but we want everybody in the office to be part of labs. So people will rotate through, there'll be opportunities to work on kind of specific research projects or component pieces that has heavy involvement in lab. And then on every project, we also have sustainability champions that are actively involved in kind of reporting and liaising with the labs. So we have kind of tentacles that reach out into every project. So just really broadly, kind of this is the kind of the premise, the way that lab operates is kind of built on a feedback loop. So, we start with research and asking the right kind of questions. Out of that research, we're able to share knowledge, and we've also recently launched an in-office intranet, so we have a way of sharing very detailed and technical information across the office. Once that research has been undertaken, we have mechanisms for knowledge share within the office, and that research is integrated into the project process. We have a series of tools and workflows that we've developed, that Shahrzad has developed, that we implement across the office. And it's never a static kind of situation. We're constantly kind of evolving and changing our process to provide the best possible outcome. So out of the research, we integrate that knowledge into the process. When we have successes, we're able to take those lessons learned and integrate them into kind of define the process moving forward for other projects. And then out of that implementation, there's always additional questions that kind of feed back to more research. So this is kind of a intentional feedback loop within the office that we perpetuate, and we keep pushing forward on all of our work.
So I'll just talk a little bit about this image, but we're going to get back to it when we go to the project case study. So one of the things that we do, as Kael mentioned, is basically we have an iterative design process, and in each design phase, it's a data-driven process. So we perform different types of analysis to basically inform design decisions. So these types of analysis that you see on the screen are basically targeting early stage analysis, but we also do compliance reports, as well as sending reports to consultants like mechanical engineers or energy consultants to the project. So the other activity that the lab does is to provide training and setting up workshops for all the designers within the office. So we run workshops on specific tools that we have in the lab, so they are empowered to use those tools within their projects. As you know, we go through a lot of different design iterations throughout the life cycle of a project's design. So being able to test each one of those design iterations is a very good capability that we have provided in-house, because you can't always ask consultants to provide analysis on all of your iterations. That's going to take time, and you're not going to get that response right away. So some of the analysis, as you see these circles integrated within the design process. We start very early on, even to support our RFP process as well. So we provide a different range of analysis, from building energy performance, doing net zero energy feasibility studies, whole life cycle emission analysis. As you know, we're going to talk about the importance of embodied emissions and operational emissions. We also do indoor environmental quality analysis, the importance of daylight in architectural design, but also its impact on occupant health and well-being. We kind of work on those. So in each of the case studies that we present, we're also going to talk about what we did as part of lab for that project. So I'll just move on to the next slide.
Great. Yeah. So we have actually ignore number 2. We forgot to take that out. We had too many slides, so we had to cut back. Yeah. So we're gonna talk about the Douin Center for Computer and Data Sciences at Boston University. The Pemerty Discovery Center was a research building at CAMH, and then a little bit about the Kindred Works portfolio as well. And then we'll get into some of the kind of more pure lab-focused research that we've done as well. So this is the first project, the Computer Data Sciences building at Boston University. So this was a project we won through competition, and the project was put on hold back in 2014 when the university decided they had other priorities. They wanted to wait until they could afford the building properly. We kind of assumed that the building was going to die on the vine, so we were happy and surprised when the project came back in 2018, and they asked us to keep going. What was interesting is that in the meantime, between 2014 and 2018, frankly, we had a kind of a hard sell with the university to try and push a kind of more sustainable agenda. When they came back to us in 2018, they said, we want a net zero building. We want the biggest net zero building in Boston. So it was kind of an about face. They had developed a very strong sustainability strategy in the meantime, so we were quite pleased about that. But we took that original design that was won through the competition and started to be developed, and then tried to understand how we could enhance its sustainability. We worked on this project with Transolar climate engineers. I'm not sure if you're familiar with them. They have offices in Stuttgart and Munich and New York City as well. But we've done a lot of work with them over the years, and we work closely with them to try and understand how we could integrate the facade system to provide some shading. So we looked at solar orientation and shading from the kind of stepped mass, and looked at how we could kind of optimize and develop a cladding system that was functional and kind of provided the project with a very kind of iconic appearance at the same time. This building's a little unusual in that everybody that goes to Boston will have at least 2 classes in this building at one time during their education. So the focus is computer sciences and maths research, but everybody has to do courses in this building, and everybody has core courses that are related to the different faculties that are in the building. But the building is 19 stories, and but the ground floor is entirely common open space. So right from block to block, it's open space, and there's a large kind of occupiable stair that takes you from the ground floor to the second floor. The other really interesting thing about this project is it's a tight site, and we knew we had to go tall. So we were very concerned and thinking about how we're going to create neighborhoods within the building. So there is a stair that runs. You can walk from top to bottom on the public open stair in the building. So each of the kind of shifts in the stack of books, if you will, correlates to a different faculty group. So every faculty group has their own external terrace, but there is a public stair that you can use to walk the entire height of the building if you want to. So we're really trying to find ways to encourage people to walk and not have to depend on the elevators as much.
Okay. So I just wanted to talk that, as Kael mentioned, this is the tallest net zero energy building in the city of Boston. So that was one of the largest mandates and sustainability targets for the project. So this project was able to achieve this net zero energy status with, basically meeting all of its electricity demand using different renewable energy sources from solar energy on-site and off-site, but also purchased electricity from a wind farm that Boston University has, and also geothermal energy on-site. So that's basically how they were able to meet this status. But internally, we were curious to see what is the balance between operational emissions, which is basically emissions attributed to operational aspects of the building, energy consumption, lighting, heating, cooling, air conditioning, and also embodied emissions. If you're not familiar, embodied emissions is basically the impact of anything that goes into the building, from building materials to mechanical systems, finishes, building enclosure, structural system, from the way, basically throughout the whole life cycle of a material, from its extraction to production, manufacturing, how it comes to site, and then what's the end of life of a product that we have in the life cycle of a building. So what we did was to do a study for this project, just to kind of see a balance between operational and embodied emissions. So in terms of operational emissions, even though this is a net zero energy building, we have to consider some indirect emissions with purchased renewable electricity. So as the building is the way, like as you see it as designed, you see that 80% of the total emissions for the building for a 60-year lifespan is for embodied emissions, the amount of material that goes into the project. But if we were to design this building as a regular project where there was no renewable energy on site, so all the electricity was provided by the electrical grid in Boston, we would see that almost half of the emissions would be attributed to operational emissions, and the rest would go to embodied emissions. So it kind of shows that we were able to really shift that operational emissions with these strategies that we implemented on this project. And as Kael mentioned, this was a project in the making from a very early, like from 2014, you said. So embodied emissions was not a priority on many projects and was not part of the discussion at that time. So the approach that we took for the analysis for this embodied or life cycle analysis was to consider all the components of the building, from mechanical systems, structure, enclosure, interiors, and even the landscape on the project, to see what their embodied emissions is. And we did kind of a breakdown, and you see that more than almost 60% of the embodied emission goes towards the mechanical system and the building enclosure mainly for some of those shading elements. But if you look at, for example, the Toronto Green Standard and the standard practice in the industry to measure life cycle analysis, it only requires core and shell, so only structure and enclosure. So if we were to just follow the industry standard to measure the embodied emissions for this project, we would miss about 47% of the embodied emissions. So this kind of just goes towards that knowledge sharing aspect. We kind of discussed this internally and highlight the fact, and with the research partnerships that we have, for example, we have a research partnership with the Center for Sustainable Built Environment at U of T in the Civil Engineering Department, and we kind of highlight all the time that, one of the important factors is to expand this core and shell to especially interiors, because interiors have a very high turnover and a shorter lifespan, so we have to be mindful of how many materials we put and what's their durability and lifespan. So this is just a study that we did for this project.
Okay, thanks. Thanks, Shahrzad. Yeah, so next we're going to talk about the Temerity Discovery Center, which is a brain research center at KMH, so down at Queen West and Shaw Street, which was the site of the original provincial, I guess back then it was called the Asylum. So there was a conscious decision with KMH to keep the wall that was actually built by they called them inmates at the time, around the building. So this building's a little unique in that it's dedicated completely to research on the campus, and it's meant to be a kind of a showcase for KMH, but also a way of attracting international talent to the research center in the building. So the building's currently under construction, so it's just about at grade right now. They're just starting to pour the ground floor slabs. And KMH set some very aggressive sustainability targets. They wanted to be TGS Tier 3. They wanted to be LEED Platinum, and they were looking for a minimum 60% reduction in energy. So That's a challenging thing when we're talking about a lab building. It's just largely wet labs. There's a vivarium research center in the basement. So it took some really kind of broad, unique thinking to figure out how we were going to be able to pull that off. Then, in addition, they were looking for a kind of 50% reduction on carbon emissions and looking for a 50% reduction on water as well. So we are currently tracking as achieved on all three accounts, but that needs to be proven in the building. So the building's also pretty unique in that it has a double skin that wraps around the outside of the building. We have a bit of experience with double skins in very extreme climates as a mitigation device. Here, it's really more about resilience and providing the longest possible natural ventilation season into the building as possible. So there's a lot of passive thinking. Again, we worked on this very closely with Trend Solar. There's a lot of strategies that invest deeply into passive arrangements. So there's a kind of a stepped stair that runs up through the building. It's an open circulation space, but it's also used as a solar chimney. So the air that's brought in through the double skin, it's acclimated as it moves through the double skin, moves into the office space, and then moves up through the central atrium into a large plenum up in the penthouse. That kind of claimed air that's already treated is mixed with additional incoming air, and that air is then pushed back down to the lab spaces. So we're able to kind of cascade the air through the building and then back into the labs. So we can dramatically reduce the amount of acclimating and fan power that's required to move the air and treat it as it comes into the building. And then we have a lot of very aggressive heat recovery systems in the building, so we're able to extract the cooling or heating energy out of the building. And this is a blow up of that kind of double skin condition. So the idea is that the outer skin, the operable windows and the outer skin are controlled through a series of automated motors. It's all driven in real time by weather stations up on the roofs. So they track wind speed, rain, humidity, temperature, and solar radiation. And then they make decisions about whether or not to close or open that outer skin. The inner window is controlled manually, so people have the opportunity to kind of fine-tune that window position as they want. And then through the building, we have a raised floor system, so we're using displacement ventilation, which is the kind of lowest possible energy use for a ventilation system. So as the air comes up through the floor, it heats, and then it stratifies against the ceiling, and then moves back. The warm stale air moves back against the ceiling and up into the atrium. And then we also have an automated blind system which lowers tilts according to the amount of glare that we have and solar gain at any time. So through the use of the double skin, we can a little more than double the length of the natural ventilation season, because that double skin kind of acts as a greenhouse, but it also acts as a way of kind of trapping heat in the summer. And then we can cut out the solar gain through the use of the blinds. So it's kind of, I use the analogy of a kind of a light K-way jacket rather than a heavy parka. So you can open and close the jacket as you need to cool off or warm up. You can kind of trap that body heat inside and use it to help you keep warm in cool weather. Another really unique feature of this building, it is a mass timber hybrid building, and it's a very unique structural strategy. So we worked with Dave Bowick at Blackwell to develop the structural system. We knew we wanted to do a mass timber building, but at the same time, we wanted to do a curvy building, so they don't necessarily go well together. So Dave, being the kind of always adventurous person that he is, he developed a strategy that uses a kind of composite system. So it marries the mass timber on the bottom with a what's called a bubble deck, so a concrete slab with bubble voids in the middle of it. And then on top of that is a raised floor mechanical system. So one really interesting advantage of the system is that you can build this thing without drop beams. So you place the wood, and once the wood is in place, you can use that as formwork to pour the bubble deck on top. So yeah, you get away without using any of the drop beams that you normally get in a mass timber system. So the way this works is it also gives us a longer than normal span. So we get about 33 foot, about 10 meter span by 6 meter span, which is really long for a mass timber system, even a composite system. On top of that, we place rebar cages, and in the rebar cages, we place these, they're basically plastic balls, beach balls. So we call these slab voids or bubble deck. So there's a series of keys and shear plates in the wood that allows the rebar and the concrete to kind of tie back to the wood. So the wood is being used in tension. The concrete on top of the deck is being used in compression. And because instead of having a fairly shallow floor plate, we're applying these forces over a taller, deeper floor plate, which allows for more efficiency in the application of the tension and the compression. And the other advantage is if we have atypical structural conditions like cantilevered edges or curved edges, we can adjust the ratio between the wood and the concrete and the bubble deck to allow for integrated beams or strengthened edges where we need them to make the shape work properly. As mentioned, it's a research building, so it's about 40% wet lab space, and the other remaining portion of the building is open office space and event space. So it's pretty unusual to have wet labs in a mass timber building. So this was an interesting application of that approach. This is an image of the facade.
So one of the important things in this building was to understand indoor environmental quality, especially with daylight, because of the double skin facade and because transparency and visibility was a big part of the design intent for this project. So we had to understand how the impact of double skin facade and the motorized shading system is going to impact the daylight perception and glare control within the space, but also because this project was targeting LEED. So as part of LEED, we wanted to see if we are eligible, for example, for any daylight credits that we can get. So we did an analysis for this project, which provided a little bit of challenge in terms of performing it and understanding what spaces we need to consider, for example, for this type of analysis. So as you can see, this building is eligible for 2 credits for daylight, meaning that in terms of like daylight availability and daylight access, it presents a good ratio for most of the spaces, given that the building, basically these longer facades are east and west facing. But also we have some glare in the building, but as Kael mentioned, that is all controllable either with manually internal blinds or the motorized system. So overall, we observed that even in places that we were not expecting, we could get some good direct daylight within the space, and the rest would be indirect daylight in deeper places because we have open plan office in the middle of the building. So that's what we did as part of the lab, and we directly submitted that report for LEED certification.
And then last example project I'm just going to talk about is the Kindred Works portfolio. So Kindred Works is a developer that is pretty, let's say, different from a lot of other developers in that they have they have a focus on carbon neutrality, low energy, and in particular working in neighborhoods and existing spaces to prioritize social impact. So they'll think not only about kind of where's the right demographic for our project, but where can we make the most impact. So they have a kind of broad range of projects, that everything from townhouses to high rises. They do prioritize using light light wood framing and mass timber wherever they possibly can. And then we have spent a lot of time, which Shahrzad will talk about, looking for kind of low carbon assemblies and looking very carefully about what the carbon impact is of all of our decisions. All of the projects are CAGBC net zero, and they will not necessarily be Passive House certified, but we're using Passive House strategies in all of these projects as well. This is an example of one of the interior projects. So, as the code develops and as mass timber kind of works its way back into the codes, we are expecting we're going to be able to kind of expose more of that mass timber. At the moment, the mass timber projects that we're doing with Kindred Works are entirely encapsulated, but it's the first step in kind of getting the industry very comfortable with mass timber as a building material. This is a project that's about to get started on construction. It's called Green Cedar. It's out in Scarborough. It's 12 stories tall, and it's mass timber, and it's fully encapsulated except for the ground floor. So it uses on-site renewables, has geo-exchange, and so Scope 1 emissions are 0%. So it's entirely electric. One thing that's kind of interesting about Kindred Works is they work very closely with the United Church of Canada. So the United Church has a lot of properties that are not being well utilized, or projects that have some existing buildings on them. So they'll work with the United Church to understand how they can make better use, increase density where housing is needed, but also add to existing neighborhoods, and working with the church to kind of make sure that the outcome aligns with the intent of the original mandate of the church.
Yeah, so the entire portfolio has a very strict sustainability requirements and targets. So one of the things is to understand the type of enclosure that we want to put, analyzing different scenarios for both thermal performance but also embodied emission performance. So the two charts that I'm going to show is basically using the same backup wall for timber frame construction, and in this figure we're just assessing the thermal performance of the building enclosure, and the only thing that changes is the bottom part of the stack, which is the cladding type, which doesn't have a lot of impact on the thermal performance. As you see, the largest impact is going to be the insulation, which has the highest thermal performance in this thermal resistance in this case. But if we go to embodied emissions, which is characterized by the global warming potential, you see that if we keep the backup wall the same, but just change the cladding, the total embodied emissions of the different building enclosure, this is just for the wall, changes considerably. We consider different products from treated wood cladding to aluminum siding, wood siding, ceramic, terracotta, and so on, just to give the team a better understanding of what options they have, and if they want to achieve their target, what direction they should go, basically. And as Kael mentioned, these projects are targeting net zero. Most of the projects that are like in townhouse format, they already have PV mounting systems installed on them. So one of the things that we do in the lab is to do in very early stages to do a PV feasibility study to understand where we can actually generate the most amount of solar energy on the site. Can we actually apply it on the building? So this, I think, is for early stages of the Green Cedar, and we couldn't put PV modules on all the roofs because of the Toronto Green Standard green roof system. So where do you put it? Where do you get the most amount of energy, and how much of your electricity consumption can you meet with this amount of PV that you are putting? For example, in the case of the last example, this is early stages, and obviously this number change once we get into the actual system and efficiencies. But in different cases, you see that we can meet 20%, even 100% of our energy just with PV modules. But if we don't meet it with a lot of solar energy, we have to go towards other renewable sources, such as geothermal, or offset it, basically. So, yeah, I don't know how we're doing with time.
I don't know either.
If we can. So, I don't know. You tell us how we're doing with time.
Talk faster? Okay.
Okay, we can keep going. Okay, so Some of the case studies, these are specifically for things that we did in the lab. One of them is kind of a research project that we presented in different conferences. And the first one is a tenant improvement lifecycle analysis of our office. So this is our office. Basically, the intent, as I mentioned, was to understand the impact of interior finishes on embodied carbon of a project. So the focus is always on structure and building enclosure, and we just wanted to see in the case of our office, the materials that we chose for ceiling finishes, for wall finishes, carpet, and so on, what does that amount to? And the other part of this research was to see if we designed the office in a different way, given the same area, given the same layout, what would be, if we went business as usual, what would be the result, basically. So the first part of this research was just to do a takeoff and go to design drawings or just go around the office and measure stuff or count the number of furniture pieces, for example, that we had. And then we put that into the software that we use for lifecycle analysis. And the results basically showed us that our current office, with the way it is designed, so our office is a completely open plan office. We only have some enclosed meeting rooms with glass partitions. But we also have all the desk spaces, all the workstations that we have are reused from the old office, so they're not new. If we wanted to purchase all of them as new, then the results would have been very different. So in the case of a conventional office design, I took the same drawing, floor plan, and designed perimeter office rooms, closed perimeter office room, which would account I think it got to 20 office rooms. And then we also consider all the furniture pieces to be new, which is something very normal when we go to a new space, for example. And you see the difference. So that's the numbers that you see is in terms of kilogram of carbon dioxide per square meter. So that would be the difference if we wanted to go with a conventional office. And the number is in line with past research that has been performed, which is very limited number of research that has been performed for interior life cycle analysis. But as you can see, I don't think I have it in here, but the largest amount of carbon would go towards furniture, which is still a developing field in terms of values that we can get. So as a result of that study that we performed, we wanted to do more and more life cycle analysis studies in-house because that is something that architectural designers can directly control. We, probably not the structural components, but definitely for the enclosure and the interior side, we are directly responsible for the types of materials that we select and the amount of materials that we select. So we came up with this new tool and guide to help us perform this life cycle analysis in-house. So that tool is called the Carbon Engineering Guide. And as I mentioned, our tools and guidelines are all in line with the design process. So we kind of mapped this life cycle analysis with the costing stages that we have, because once you do the costing and data collections for the costing, you can basically match it to the data collection for your life cycle analysis. And, the accuracy changes as you move towards the final stages, obviously. And then you can kind of control the amount of data that you take off. So what we do for this life cycle analysis is basically very simple. It only has two parts. The first part is that you need to do a data takeoff or extraction from your projects, like what is the amount of drywall, for example, for this space in terms of square meters? What is the volume of concrete used in the buildings? So that would be the first takeoff, which is the amount. And then you go to what we call EPDs that you might have heard of to get the environmental impact of that specific material that we are choosing. And then you can kind of select and compare a different range of materials, as I showed you in the Kindred example. So the tool that we developed is for all building components. Again, this is not an industry standard. Industry standard is just for structure and building enclosure, but internally, even if it is just for our own information and building our own database and internal benchmarks, we do a whole building lifecycle analysis. So we do it even for interiors, MEP, and landscape. And as I mentioned, it has three parts: data takeoffs, the analysis part, and then reporting it, whether it's for compliance, like the Canada Green Building Council Net Zero Carbon standard, or just for our project.
I'm going to fly through this because I think we're a little late on time, but this was a project that we undertook with Queen's University and the University of Toronto as well. And it was for the city of Kingston, but we were looking for means and methods for reducing embodied carbon within concrete construction. So I'm sure you've heard these statistics before, but about 42% of annual global carbon emissions comes from building and infrastructure. And 15% of the world's embodied carbon comes from just 4 building materials. And of that 15%, 8% comes from cement. So cement is so endemic and kind of embedded within the construction industry, it's not really realistic for us to expect that we're going to be able to turn on a dime and start to build everything out of wood. There's just not enough wood to make that happen. So we need to think about how we can use the technology and the methodologies that we have now that we can actually make a difference in the amount of embodied carbon. To compound all of this, this is a kind of crazy statistic, but by 2060, the building floor area across the entire world is expected to double. So given the immediacy of the issue, we were approached by U of T and Queen's University to work with City of Kingston, and then we started to assemble an industry team. We paired up with Arup, doing the mechanical, electrical, and structural engineering, but then also a number of industry partners. Acon, the constructor, Lafarge, the cement and concrete supplier, and then a couple of precast companies as well. So when we started on this project, Queens and U of T were already doing some interesting testing on shape optimized beams and fabric formed beams. So looking at how they could reduce the amount of cross-sectional concrete within a beam and still have it working efficiently. So as kind of a centerpiece in this project, the intent was to have 4 different research beams that looked at different shape profiles. And within those beams, they had embedded fiber optic cable so that they could measure the deflection under load in real time within the building over the life of the building. This is what the project ended up looking like. So this was actually a small classroom for the City of Kingston Fire and Rescue Department. So this was kind of in their training campus. So they have one of those concrete buildings that they set on fire and they send firefighters in there. This would be sitting next to that thing. So it was meant to be a kind of standalone classroom, but also provide a large covered area to get out of the sun and do some outdoor training as well. So when we first started looking at this, we were thinking, all right, well, using the building form that I just showed you, if we take a kind of conventional business as usual approach, we'd be looking at about 250 cubic meters of concrete. So that's about 86,000 kilograms of concrete. And then, the kind of obvious thing is, well, let's use some low carbon concrete. But we quickly realized that the most we can actually reduce the amount of carbon by is about 30% without dramatically changing the structural design of the concrete or how the building's built. So if we cast this concrete building in place, as soon as you start to reduce the amount of cement, you have to let the concrete cure for a longer period of time. So then you run into a problem where all of a sudden, instead of a 28-day cure period, if you have a 56 or even longer, you dramatically impacted the construction schedule of a project. So we knew right away that that was not an option. So we set about kind of understanding how else we might be able to approach this. So instead of just kind of applying a kind of quote unquote standard set of structural systems, we started looking at how we could shape optimize or really kind of save concrete mass wherever we possibly could. So and then we started to look at kind of odd shaped columns and beams and understanding and even ways of avoiding the slab within the concrete. And we kind of came to the point where we realized, okay, well, the industry can provide low carbon concrete with about a 70 to 80% reduction, but it means that we're going to have to figure out a way to allow the cure times to be substantially longer. And that kind of in a roundabout way led us to thinking about precast concrete. Because the advantage of precast is you have a lot more control over the form, the quality, because you're doing it in enclosed and controlled space. But it also, the concrete can sit in that form for a longer period of time. They can strip off the form and the concrete's strong enough that it can be self-supporting, but it's not under load yet. So it can cure for a longer period of time without any danger of the concrete becoming impacted. So this is how that played out. We kind of started with a kind of business as usual structural approach. We were able to cut about 40% of the concrete just by looking really carefully at how we were using the concrete and the beams and columns, doing things like the V column that you saw in the image. So we have two columns that are essentially sharing one base, and really radically reducing the amount of below grade concrete as well. And then because we were using the precast elements, we were able to reduce the concrete by about 70% and have all of the concrete poured and stored in the precast facility, which means that, much like a mass timber building, you can just bring those precast elements to site and erect them with a crane. You can be done in a couple of weeks rather than months and months on site. So there's also additional savings in terms of site logistics and spending time on site and, formwork, stripping the formwork, all of that time and effort that goes along with that. So that led us to a really kind of a kit of parts where we had kind of about a half dozen typical products that we developed, and we're working with a precast engineering company out of Italy called Shahrzad. So they helped us to kind of develop these strategies, and we kind of use those modular elements to develop the form of the building around the component pieces. So it was a kind of a back and forth exercise where we look at what we wanted to do, what the shape of the building was going to be, how could we make that as modular and consistent as possible. So the concept was always that you'd have this kit of parts that you could basically expand infinitely in any direction. You can build slabs or platforms. And then, the next step in this would be to start to apply multi-story applications and understand how that precast system might work in a larger building. So this is kind of a cross-sectional perspective of what that building looks like. So you can see the kind of shaped beams and the voided slabs. And then we also looked at kind of the structural systems for the low grade and looked at developing a kind of very, very lean grade beam system with Arab. And then even doing precast foot pads for the columns, so that in principle the building could be erected and put together in about a week and a half. And then the other aspect of this is we started to look at other low carbon building products. So a lot of the concrete was exposed, and because this is all precast, we had a lot more control over the kind of the look and texture and feel of the concrete. So we were able to kind of do some experiments with that. And then for all the kind of ancillary products, we used 100% recycled carpet, wood fiber acoustic panels on the ceiling, and then also looked at using a fiberglass curtain wall system. And then the cladding that's not concrete panel was a GFRC that we were looking at using, which uses volcanic ash instead of Portland cement. So I guess to close things out, I think we were thinking, what could we pass along to the group? And kind of a lot of these are kind of elements that we focus on and kind of try to encourage within our own staff and within the lab. Focus on topics that fascinate and challenge you. Always ask more questions, and learning more is never time wasted. So I can say that within the office, the people that ask the most questions, the most inquisitive, the most passionate people are the people that are really the most valued. And so I think it's not just that you're learning more, but other people are recognizing your passion and will want to encourage you. Kind of always think about, is this the right way to do it? Don't be afraid to challenge the kind of status quo and start to think about, would I be comfortable? Would I be happy doing this for myself? So think about how the work that you're doing is interpreted and conveyed by others. And then keep moving forward. I think that's really the kind of basis of what we do at Lab, is like little steps are still steps forward. So keep pushing the process, keep making the changes, and kind of making sure that you're sharing that knowledge and working together with the rest of your group to provide the best possible outcome. Thanks very much.